Hello and welcome to Skill Hackathon. This is our SQL Interview Questions and Answers series. Today we are going to look into one of the SQL question which is going to test your Windows function knowledge. Now the question is rotate students within every 3 adjacent seats in SQL and leave incomplete groups unchanged. So we have been given an input table where we have seat ID 1 to 3 till 8, then student A, B, C, D till H. And now we have been given an output table where we have seat ID in the similar manner 1 to 8, but the students are changed. So in input table at seat 1, the student was A, but in the output table at seat ID 1, the student is C. Similarly for 2, the student is B. In the output for 2, the student is A. And for seat ID 3 in input, the student is C, but in the output it is B. So we have been given the rules how the seat IDs are changing for the students. So seat IDs are ordered based on seat ID. And the second rule is students should be rotated within each group of 3 adjacent seats. So seat 1 will go to the second student, seat 2 will go to the third student, and seat 3 will go to the first student. So the same pattern repeats for seats 4, 5, 6, 7, 8, 9, and so on. Now, if the last group has fewer than 3 seats, students in the group remains in their original seats, like what happened with seat ID 7 and 8. So we have 7, 8, 9. 9 is not there. So in this series of 3 seats, we have GH only. So these 2 students won't be changing their seat. Same is reflected in the output as well. The fifth rule is seat numbers must remain fixed. Only the students are moving. So seat IDs are same, only the students are moving. Now this we can check through this table. So we have seat ID 1, 2, 3. So in a group, we have 3 students, 1, 2, 3, student ABC. Now in the output, the student C will move from seat ID 3 to 1. B will move from seat ID 2 to 3. And A will move from seat ID 1 to 2, which is reflected in the output. Same for 4, 5, 6. But for seat ID 7, 8, 9 is absent. So the students will remain in their original seat ID only. So GH. Now let's go to SQL and check how we can do it practically. Okay. So I have already written the query to create the table classroom seating where we have seat ID and student. And I have also written the query, insert the values in seat ID and students. So we have seat ID till 1 till 8 and students from A to H. So this query, I'll be putting it in the description as well so that you can create the table and insert the simple data and try it on your own as well. So now let's check our table. Select star from classroom setting. This is our table name. Now let's run this query. So this is our table, seat ID 1 till 8 and student A to H. Now let's check how we can solve this question. Now, even though the logic sounds very simple, but it's very easy to get wrong in SQL because window functions can accidentally cross group boundaries. That's why we need clear ordering, correct grouping, and safe rotation logic. So before writing the query, let me reiterate what we want to do is we want to rotate students inside group of 3 seats. Seat 1 should take the student from seat 3, seat 2 from seat 1, and seat 3 from seat 2. And if the last group has fewer than 3 seats, we'll leave it unchanged. The first thing we are going to do is we are going to assign a row number ordered by seat ID. So SQL tables, right? Generally, they don't have a natural order. So what I want to do is I need this row number to control grouping and rotation. So let's write the query, select seat ID, student. Now let's use the row number function. Row number over order by seat ID. And let's give this as an alias as RN. So RN is row number. Classroom seating table. Now let's check our output. Now if we see, we have row number 1 till 8 for every seat ID. So for seat ID 1, row number is 1, 2, row number is 2, 3 is 3, like that 8 is 8. Now, what we are going to do is we are going to put this query under a city. So let's give the city name as numbered as brackets. Now let's close this bracket here. Now from here on, what we are going to do is whatever logic we are going to apply for grouping, it will be based on this row number RN, not the seat ID. Okay. Now, why we are using this row number is this row number guarantees a stable sequence and avoid bugs when seat IDs are missing or unordered. And it also makes the grouping logic predictable. Now, let's put a comma here. Now we are going to create another city named as group. So let's give this as an alias as grp as brackets. Now select seat ID student RL, which is our row number. Now I'll divide the rows into group of 3 using integer division. So rows 1 to 3 will go into group number 0, rows 4 to 6 into group 1, and so on. For that, we are going to write RL minus 1 divided by 3 as grp underscore ID. So now why we are using this integer division is, so it is very simple and fast, and it will automatically create the fixed size groups and no joins or subqueries are needed. Now we are going to use the row number function again, row underscore number over brackets. Now we are going to do the partition by, and this partition by we are going to do based on our integer division. So it will be Rn minus 1 divided by 3 and order by rep, which is our row number. And let's give this as an alias as pos. So pos will be the position of the group, comma. So why we are calculating this position inside each group is, what we are doing here is we are calculating inside each group the position of each row. This will tell us if a seat is the first, second, or third seat in the group. And why we are using another row number function is we are using it to make the rotation based on the position. So we need to explicitly know who is first, second, and third to rotate the student. Now we are going to use the count function to count rows per group to detect incomplete groups. So count of star over partition by same Rn minus 1 divided by 3. And we are going to give it an alias as group size, group underscore size from. So now we are not going to use the classroom seating table. So we are going to pull the data from the numbered city. So we are going to put from numbered. So we are taking the output of this numbered city, then applying all these calculations on this numbered output. So this was the output of the numbered city, seat ID, student, and RN, row number. On this output, we are applying this logic. Now let's check. Select star from GRP. GRP is our second city. Now let's run this query. Now we can see the output. See, seat ID, student, row number, group ID. So seat ID 1, 2, 3 is in group 0. Seat ID 4, 5, 6 is in group 1. 7, 8 is in group 2. Position, seat ID 1, 2, 3, that is A, B, C are in position 1, 2, 3. Then 4, 5, 6, which is D, E, F is also in position 1, 2, 3 inside the group ID 1. Now inside group ID 2, which is 7, 8 and GH student, the position is 1, 2. Now the group size. So group size is how many students are in each group. So in group 0, there are 3 students. In group 1, there are 3 students. In group 2, there are 2 students. So based on this logic, we are going to rotate the students. Now we are going to build the final output. So if a rotated student exists, I will use that. Otherwise, I will keep the original student. So for that, we need seat ID in the output. Then we need student. So for the student, we are going to use the coalesce function. Now, why we are using this coalesce function? Because coalesce function handles null values cleanly, and it also keeps the incomplete groups unchanged. So first, let's name this from GRP as G1. Okay. G1 dot student. Let me put G1 here as well. G1 dot set ID. Now, before I complete the coalesce, right? The statement completed, so it's not complete. We are also going to use the self join function to rotate students safely. So let's write left join the same table GRP. Let's name it as G2. So now we are going to join the table to itself. So each seat can pull a student from another position in the same group. And what we are going to do is we are also going to restrict rotation to groups that have exactly 3 rows. So the condition will be on G1 dot grp underscore id equal to G2 dot grp underscore id. And the condition is G1 dot grp dot size, which is group size, is equal to 3. So wherever the group size is 3, on that group only, we are changing the students. That is, we are rotating the students. So now call as G1 dot student, comma G2 dot student. And we are going to name it as student. Okay. And one more condition, G1 dot was equal to 1 and G2 dot was equal to 3, or G1 dot was equal to 2 and G2 dot was equal to 1, or G1 dot was equal to 3 and G2 dot was equal to 2. Now this whole logic, right? 3 conditions, right? This will all be under this AND statement. So let's put the brackets. Now here, this is the actual rotation logic. So here the first seat takes from the third, second seat from the first, and the third seat takes the values from the second. And writing it this way makes the logic very clear and easy to debug. And why we are giving this explicit condition is it's easy to read, less error prone, and it's very interview friendly logic. Now we are going to order by seat ID. Now let's run this whole query once. Now let's check our output. Okay, we did something wrong. Let's check. Okay, so what we did wrong is, let's look into the query. Okay, so here in coalesce, okay, it will be G2, it will be G1. So coalesce G2 dot student, comma G1 dot student as a student. So let's run this query again. I think it will work. So let's run this query. Now let's check our output. So seat ID 1, student C, seat ID 2 is student A, seat ID 3 is student B. So 4 is F, 5 is D, 6 is E, 7 G, 8 H. So we have rotated the students in each group. So in the last group, 7, 8, 1 was missing, the 9th one is missing. So it's remained unchanged. So this is how we can solve this query. So this approach avoids tricky lag and lead bugs. So we can also use lag and lead function here, but it's tricky using lead and lag functions. So using row number only, we can solve it easily. So by using row numbers, grouping and a self join, the logic stays clear and safe. So this is the kind of solution that works reliably in interviews and real projects. Now let's quickly recap what we did. First, we created a clear row order using row number because SQL tables don't have a natural order. So the row number we created is RN. Then we grouped rows into blocks of 3 and identified each seat's position inside its group. So we created a group ID, then identified the position, then created a group size column as well. Then we rotated the students only when the group had exactly 3 seats, and we left incomplete groups unchanged. So instead of relying on tricky leg and lead offsets, we used a simple self-join to make the rotation logic explicit and safe. So the key takeaway from this is, when window functions starts getting confusing, switch to clear row mappings. It's very simple and readable logic always. We should always remember that simple and readable logic always wins, especially in interviews. I hope you got an idea how to solve this query. If you have any questions, you can put it in the comment section and we'll reply on that. And if you have any interview questions which you need us to solve, you can also put that in the comment section. We'll look into it. Thank you for watching. We'll see you in the next video. Happy learning.